Hello everybody, today we're going to look at number of solutions to quadratic equations. So let's take a look at our first example here where we get two real solutions. So here's an equation that gives such two real solutions. So we identify our a, b, and c. We then plug it into the discriminant, and remember the discriminant is just the b squared minus 4ac, so it's the number underneath the square root. And we're going to plug those in, and we're going to use parentheses. We're not going to forget to do that. And what we get on this first one is we get 49. So when we look at the quadratic formula, let's take a look at that here real quick. Notice we have everything plugged in here. We have our 49 right there. And the question is, why does this give two real solutions every time? So we're going to split this solution off for a second. If we do a little bit of work here, I'm going to skip to the final step. What we end up with is x equals 1 and x equals -6. And that's always going to happen when we have a positive discriminant. We're going to get two, and what I mean always happens is we're always going to get two real solutions. Sometimes they do look like fractions or decimals, or sometimes they still have a square root with them, but what we see when we look at the graph is this. We're going to see two real solutions. Notice we have, if I look at the graph here, we'll circle our solutions. There's -6, and here's +1. Again, they won't always be nice even integers, but there'll be two real solutions, which means our graph will always look like this. We'll always have it crossing twice on the x-axis. Okay, now we're going to look at where we get one real solution. So let's look at an example of an equation that gives us such values here. So here's our equation. Again, we're going to identify a, b, and c. We're going to plug everything into the discriminant and see what we get. And in this case, we get 0. And 0 tells us we have one real solution. Let's take a look at why. So again, here's our quadratic formula. I plugged everything in here, skipped some steps to show you what we get in the result. So when I look at this case here, I've got a 0 here. And of course, the square root of 0 is 0. So if I add 0 to 8 or subtract 0 from 8, I always get 8. So the square root part kind of disappears, and so does our plus minus. So we're left with just this part. And in this case, x equals 4. Let's take a look at a graph here. And we can see that down here where we get x equals 4. And again, our calculator will estimate as close as it can. It is actually x equals 4. So we'll always get a graph like this when we have a discriminant equal to 0. We actually count this as two solutions. We call this a double root. But we're going to just say one real solution for now. Okay, our third case that we can get is two complex solutions. Let's take a look at an example that gives us that. So in this case, here's our quadratic equation. Again, identify a, b, and c. Use the discriminant, b squared minus 4ac. Plug everything in, use your parentheses, and in this case we get -24. So when we look at our quadratic formula again, notice our discriminant now is negative. So we won't be able to get any real solutions at all. And in fact, we'll always get something that looks like this, where everything is identical except for the sign in the middle. So let me highlight that sign in the middle. So as a preview, we call these two complex conjugates. They always come in pairs like this because we're splitting off. Everything is the same except for the plus minus. So in this case, when we look at the graph, notice it never touches the x-axis. And that's true for whatever graph we get. It may look like this. It may come down like this, but in essence, it will never touch the x-axis because they're two complex solutions. Okay, so just to summarize, here's a table that kind of summarizes everything here. So the top two options here kind of boil down to the same thing. So let me just kind of highlight that here. So when we look at the top two pieces here, this is where we get a positive value out. Now, it does break it down into two options, rational versus irrational. But the main idea here is that you're always going to get two x-intercepts that are real solutions when we have a positive discriminant. Hence, that's why up here in the formula in the table, it says greater than 0. Both of those cases. Now, we just have the case where it's a perfect square, where it turns into something nice, like with the example where we had the square root of 49. Whereas the second row is something like the square root of 5 isn't our answer. So they're irrational solutions. But both cases are the same. You're going to get two x-intercepts, like right here. Okay, and again, your quadratic could cross like this. Could be upside down, that's fine. but you're basically getting two solutions there that are real solutions. Okay, our next case is two cases here. We're going to do both at the same time, it looks like. So we have where it's equal to 0, and that's going to give us, as we talked about, one real solution. It'll always look like that. It may come up from the bottom and bounce off. Again, we call that a double root when we get to polynomials. And then our last case down here is where the discriminant's less than 0 or negative, and that's going to be where it never crosses the x-axis. So that's our summary. Hopefully that helps. That is helpful, say, when you're taking the ACT and you're working really quick and you have to just figure out to eliminate some answers. You could do the discriminant real quick and then figure out which answers you can eliminate or something like that. Or if you just want to confirm your answers, you can use your graphs to do that. Hopefully that helped. Have a good day.